Hi everyone. I'm going to go over question number 9.39 from the Chapter 9 Bingo Problems. The question says, the flywheel of a gasoline engine is required to give up 500 joules of kinetic energy while its angular velocity decreases from 650 revolutions per minute to 520 revolutions per minute. What moment of inertia is required? So the first thing I want to do for this problem is I want to convert these angular velocities to radians per second, because revolutions per minute don't do anything for us really. So we'll start with the initial, which is 650. So it's just simple dimensional analysis here. So know that 1 revolution is equal to 2 pi radians. And then, so those cancel, we're in radians. And then 1 minute is 60 seconds. Minutes cancel. We end up doing the math. We end up with 68.07 radians per second. Okay, now we just do the same thing for the final, which honestly we can just switch this number out for 520, since the rest is all the same. And we end up getting 54.45 radians per second. Okay. So now that we've done that, we can, I guess, get on to like the real part of the problem. I think the best way to do this is to use one of our energy equations, which is K equals 1/2 I times the angular velocity squared. And now this is really going to be kind of the change in the angular velocity, so we'll rewrite that like that. And now what we can do is we can solve for the moment of inertia, right? That's what the problem wants. So to do that, we end up getting that I equals 2K over that. All right. And I guess I actually made a mistake. The squared needs to be inside the parentheses. Makes a difference. So anyway, now that we're at this point, we can just plug in values. So we end up getting that I is equal to 2 times kinetic energy, which is 500 joules, over our final, which is 54.45. Oh, but that's going to be squared. I'll just do this on the calculator. Those are kind of big numbers. But then, subtract from the initial squared. And we end up with negative 1668.72. So now we can divide these. So we end up getting that the moment of inertia is equal to 0. It's 599. We'll just say 0.6 kilograms times meters squared. So that's what we're looking for. So just as an overview, we first had to convert our angular velocities from revolutions per minute to radians per second. We then used our rotational kinetic energy equation to solve for the moment of inertia. We did that and we got 0.6. So that is how you solve question number 39. Thanks for watching. I'll see you in the next video.